Hey, welcome back. And on this episode, we're going to get into the Z-axis. On the last one, we just kind of updated some things using this Tech2C's, Scott 3D's configuration file. So it's kind of updated some things to change some things around and kind of ranted a little bit, I guess. But that's okay. You're going to hear a lot of that if you follow these. All right, so at this point, we have done some of the frames. Now, look, I recognize that these bottom parts, they need to be moved up a bit, but we'll wait in just a minute to do that. All right. So what I'm going to do in this video, if we look at this, we're going to be, of course, we're doing the dual Z-axis version. Let me move this smaller. And we're going to be messing around with the Z-axis, which is, we're going to start with these rods, these 12 millimeter rods that handle the linear actuation on that, or excuse me, the linear guides. And then from there, we will add the motor and some other things and the lead screw. After that, after we see exactly where these should be positioned, because that'll make a big difference, we will build this frame out using the 2020 aluminum extrusions. And of course, eventually we'll plop a bed on top of there, maybe even some springs, some things like this. This is going to be like kind of a harder video. I'll probably make a few mistakes here and there. So hey, if you're watching this, thanks for tuning in. Let's do it. So I'm going to drag that over there. I'm going to use that later probably. Okay, so we're going to get to importing some shapes, and we're going to use this later. I'm going to make this large and kind of just minimize it for now. Okay, so what we're going to do is we're going to grab some of the parts from the side. Remember, here we're going to import. Hey, and be careful if you're just tuning in. Sometimes it switches back. You got to do your options. So you switch it to STL, and then you're going to go to Merge Coplanar Faces. Man, I got to tell you, when I first used SketchUp, I didn't use that, and it makes a big difference. Really cleans up your models if you're bringing in the STLs. All right, and then STL units is in millimeters, and the rest of it I don't really mess with. So let's see. I need the Z-axis. What do we need? We need the linear rail bracket double Z on the left. And these are, as far as I know, these are just, look, they're exactly the same size. These are just mirrored, one mirrored for the other one. So let's grab the left one. Okay, now again, I constantly look back at these pictures to kind of see how they go. These brackets, so let's just see if we can turn that correct. These brackets need to be turned over. So I'm going to lock this on to rotating with the left button around this Y-axis, and I'm going to turn it 180. And there you go. And we're going to now grab this again, SketchUp. You want to just usually move things one at a time. So I'm going to move it. Let's see, make sure I'm referencing the exact right part. You got to watch it because these are chamfered. Some of these are chamfered on the edges, and it'll cause you, if you're not careful, to reference the wrong thing. So I'm going to move it over, lock it on the red axis, the x-axis, and reference this. I think that's, yep, that's good. And move it all the way down until it's resting on top of this rail here. Let's take a look, make sure I got that right. Looks pretty good. Is there any space there? No. Well, yeah, it looks like there is on the vertical, isn't there? And again, I might be nitpicking here. That's probably, yeah, 0.59 millimeters. But hey, man, you know, if we're going to do it, might as well do it right. Okay, now, we really, right now, I'm not going to worry about how far over to move it. I need to get another picture of this. So let's go to thingiverse.com and pull it up, see if we can find some better pictures of that to kind of check out and see which way those go. That looks like the original single axis version. Okay. Not really showing me what I want to see. You know, I think his videos maybe, okay. Yeah, so let's take a look. It looks like it slants kind of to the outside. So that's all I was wondering. And of course this is, now wait a minute. Yeah, so this would be on that side, and as far as I know, let me double check that again. This is going to have to move over some amount this way, and we don't know how long yet. Okay, so let's just move it over here for now, and we'll adjust that later. That's a good thing about SketchUp, is it's so easy to make minor adjustments in positioning of objects. Okay, so let's get a very good top view here, view from the top. And you know what, before I even bother doing this, I'm going to try to locate the middle. Okay, that's an endpoint. And again, it's not finding another endpoint there. Okay, midpoint. Is that? Yeah, okay. It's about 12.4. Yeah, let's see if we can do a better job over here on this side. And top view. I want to get this really accurate as much as I possibly can. That's an endpoint to endpoint. Actually, there we go. There, we found it. Okay, so just the middle of that should be, I'm just going to put a rod, or excuse me, make a line going up from here a bit. You know, let's make it go up 10. All right, that's fine. Kind of located in the middle of that. Delete these. I'm just going to use this as the point. Lock it on to blue. And let's put a 12 millimeter, or excuse me, radius of 6. And now, let's take a look and see. How big was that supposed to be? 400 millimeters for the 12 millimeter shaft. Okay. So, oops, redo that. And go down 400. Throw that in there, and let's make a component of that. Okay, cool. And what I need to do now is grab the bottom part of this. And that should also help us locate exactly where this is going to be. Now let's take a look. On this drawing here, it looks like those clamp on, the bottom ones clamp on the underside, and they are the same as the ones that are used on the top and bottom here. All right, so let's grab those and see what we can find those. File, import. Okay, so this would be Z-axis, double Z left, right. I think it's this one. If not, we will mirror it, because these are all the same parts, basically, but the left and right versions are just mirrored, so that shouldn't be that big of a deal. All right, there we go, and let's spin this around here. Yeah. No. It latches on the underside, so that's how it should be, I suppose. Yeah, I don't like that, by the way. Okay, 180. There we go. Okay, and let's see. Does that tilt out? Yeah, this is the right one. So we're going to go all the way down. How do we want to reference this? We want to reference the bottom of this piece, because it's going to line up, I think, with the bottom of this rod. Right there. Okay, so obviously that is not correct. I did not do that correct. I bet you there should be maybe there's some extra, or maybe, yeah, let's see. Let's just drag that over up to this face over here. Okay, so yeah, that makes sense then. Maybe we do need to move these up. So I'm gonna grab this, shift, click all 4 of these guys, and yeah, that looks right. I'm going to move these up a bit to match that And hey, you know, if you can't figure out what I'm doing here, just give me a second. I will bring this home. Trust me. And we'll move this back down. No, I forget. That's kind of a pain in the butt in this program. Okay, and so that should be on the right level, but I never did line that up correctly. Okay, here it is. And the good news is I think these are going to be exactly like, whoa, move my view there. Okay, that looks good. Double check things, look at it from the bottom. Perfect. Okay, and the alignment from this direction. Okay, maybe that is it. Maybe that's how far you need to be. I don't know for sure, but we'll find out later. Now, either way though, I'm going to start by making these into a component right now, just so that if we move them around, they're not going to get screwed up too badly. Okay, we've got one of those done, and you know what? I feel like we should add the bearing holder there. Now again, let's take a look at this. Now for this one, I forgot I need to pull up the video. So, well, let's find, do that over here so we can pull up the video that he made, because this is what kind of taught me, gave me a really good view of it. Okay, so there's that. I've kind of found it finally. Sorry, I probably should have had that brought up. Here it is, this one right here. And I was actually right on that spot. That's cool. Okay, look. So if we take a look here, you can see this, and my terrible internet. I mean, it's so bad. Okay, because like YouTube autos to 240p. Nasty. Okay, so let's take a look here. And so these are going to be, with that corner is the inside of this thing. Okay, so that kind of helps a little bit. And these are going to be LM12 UU bearings, which we will find in the 3D warehouse. I think they're in there, so let's go ahead and grab those right now. So let's go grab the 3D warehouse. LM12UU. There it is. Let's put that right into the model. Yeah, I kind of like that feature, how that you can do that. Okay, well, this has a bunch of labels and things like that we're going to need to clean up and get rid of. All right, so I'm going to just go ahead and explode these until I can select just these things. Yep. Click these labels. Again, you have to go into it, and okay, we have to explode this one now. And we're going to get rid of that, and that. We don't need those. We don't want them. Okay, let's do this and make a component. Okay, there's an LM12UU, and hey, I'm going to be honest, I don't always trust the things that I find on the 3D warehouse. So let's make sure we've got the right stuff here. I've used this one before, and I'm pretty certain, but okay, 21. Oh, my dog is moaning and groaning. She didn't like the 21. About 30? Is that right? Wait a minute. Oh, okay, I'm measuring from this. See, that's bad. Let's go all the way from the front. Okay, 30. Yep. All right. And, you know, LM12Us, I think that's correct. That sounds correct to me. I think it's right. So double check that. Rotate these 90 because they need to be upright. And let's go ahead and this is a nice thing about grabbing things out of the warehouse rather than STLs, is you can actually reference the centers. That's great. And where does that center need to go? Let's get our top view. Well, it needs to go right anywhere on there really on that line. That's fine. Okay. There we go. Hey, that doesn't look right. Well, don't worry. It's not supposed to be there. It's going to be down here a little ways. Okay, let's import the bearing holder, or whatever they're calling that. Z-axis bearing holder. Yep, that's what it is. Okay, this one is imported right here, and okay. So let's see, this, if it was on the back corner over there, let me see. I think I'm gonna have to rotate it on the red axis. Whoa. This always kind of stumps me here how to do it. Okay, so let's see. So that, first of all, let's just do it 90. Q for rotate. And let's do it 90 degrees this way. I think that's the orientation. No, that's not correct. I need to flip this 180 this way. Okay, so that is, I think, the correct orientation. No, that may not be right either. I don't know. You know, the first time I practiced this video before, and the first time I did this, it took me a little while too, to be honest. It was kind of a brain bender. See, that would be for the other side. Yeah, okay. Let's go 90 there, and then you know what I'm gonna do? I'm just gonna flip it along the red. Oh, that didn't work. Oh, because it's what the components. Let's just rotate it 180. I think that would do it. Yeah, I hate some of these things, like rotations and things like that, doing them in your head. Okay, there it is. I think that's right. Okay, so now we're going to get top view. Hey, and when you watch me doing these things and I look like a moron like there and you think even I could do that, you know what? I would like to stress the point that you are absolutely right. You could do it. If there's anything that's the point of my channel, it is that you can do it. So if you ever see me fumbling around and you think you can do it better, you are probably correct, by the way. Okay, that does not line up correctly, and I know it doesn't matter, but let's try this. That was off just a bit. Top view. Okay, that looks good there. The red axis. I think it just switched at the end there. Let's try again. All right. Okay. I think that's lined up, but we will see. All right, so I'm going to move this all the way down. And we'll put it right now at its maximum position, which would be right up here. Okay? So that would mean that this guy would have to move... Oops. Up to the top here. You know what I'm going to do right now? As you can see, as I'm moving the cameras around, some of these frame parts are starting to get in the way. This is kind of a cool trick. It's not a trick, really. But let's show the tray. That should be over here. And let's go to layers. I'm going to add a layer with a plus button, and we'll call it 3030 frame. Okay. So now we have made a second layer, and I'm going to grab, let's grab this 1, 2, 3, 4, 5, 6, 7, 8, 11, 12 lines on the cube, 13, 14 for these extra two, and we're going to go up here to Entity Info, and I'm going to change these to 3030 frame. Now, what does that do for us? Okay. Well, all the rest of the stuff is on the default layer. The 3030 is now on this one, and I can turn it off. And it just gets that stuff out of the way. I can make many different layers if I want to. So that turns out that's pretty useful, and it would have been really useful. I should have done this a while back when I was shortening up the rods on video 3, but I just didn't think of it. So, okay, there it is now. Okay, so now we have that. That looks a little bit easier. And again, you'll see me, I'll probably be toggling that on and off. And I don't feel like I need to see quite so much. Whatever. All right, let's move this. So it looks like this would probably ride down just a bit further. And I'm going to reference the top of that same bearing. And we're going to copy it by clicking Control. Whoa, I just undid that. Lock it on that vertical axis so it doesn't move left or right, or on the X or Y axis, and it'll just move on the horizontal. All right, so that's going to be about right there. And for right now, you know, earlier I made this component. I'm going to click Shift, make a new component to add that. Whoa, whoops, we forgot the bearings, didn't we? And I'm going to make these into a component first. That's what I'm going to do. See this? Because this is a slider that kind of moves, and so let's make that a component. And then this, shift this other component I made, make it a component. And that looks pretty good. All right, so we are ready to move on. So let's put the frame back on there, because we're going to need it for this next part. And you know what? I'm going to move this just way out of the way. Keep it kind of there, because later we will adjust this. And how are we going to adjust it? Well, we could do it now, actually. Now I think about it, this might not be a bad time. But first I'm going to put down the motors, okay? Or the motor and the lead screw and the motor mount. So let's go down here. Let's go to File, and we will import. Okay, Z-axis, nut bracket T10. We'll need this later, but we will need the Z motor mount. Make sure there's no other things in here, because, okay, there we go. All right, Z motor mount. There it is. Now let's see how this thing goes. I have to look at the video to make sure I get this right. Okay. So here we go. It looks like it rests on, this tab rests on the upper side of that lower rail. And this will help for later on. You can see that the nut bracket rests on the upper side of the bed railing when we build that part. Okay? Notice you can see the fasteners. We're not going to put those in our model. You know what? I'm all about making a good model, but man, I think that might be a little bit too tedious even for me, you know, and I can be very, very tedious. So, all right, let's rotate this, let's see, 90 this way. No. Yeah, gosh, I hate it. You know, I should always turn the stuff the correct vertical orientation first. I think that makes it easier. So let's go 180. So it needs to go over this way. 90 degrees. All right, let's put that on the rail. Actually, let's line it up first with the middle, or actually, let's go down to the rail. That'd be good. So definitely want to make sure my layer that I just made is turned on, because we need to reference where the bottom rail is. There we go. Lock it on red axis and slide it over here. For right now, though, I just want it lined up with the middle of the drawing, and you know, we may have to shift that later. That's one thing I couldn't really find, is how much shifted forward this should be, but maybe that'll just be a part of what we modify later. And again, hey, if you have any answers to these sort of riddles that I'm kind of posing, like, I wonder where it should be, please leave those in the comments, because maybe there's something you know that I don't know. I'm going to go in here and copy this motor that I made, this 48mm one. And if I remember right, you can't use 48mm motors for these bottom parts. It's just, well, unless you put feet on the bottom of it. Because if I remember right, there's really not, well, we'll see. All right, so let's do this real quick. Let's just, how should we do this? Well, let's grab the midpoint of this, one at a time. Boy, that is way off, isn't it? Let's get a vertical view from the top. Oh, that doesn't help, does it? Okay, well, time to make a new layer. X gantry. Or would you call it a Y carriage? I don't know. But this thing is going to... Ooh, I never did regroup this stuff. Okay, let's do that. This, belt, the carriage, and this. I think that's it. Yes. Is it? Yeah. Let's make a component, create, and then we're going to take that component and we're going to throw that in the X gantry. And we're going to make it disappear. It's still there, of course. We just can't see it, and it gets out of our way while we're working. All right, so where was I? Where did it go? Whoa, this motor is way the heck out there. All right, so first of all, let's align it along this way, which should be right with the middle. That's easy enough. And this way, perfect. Okay, looks pretty good. And let's just see, for curiosity's sakes, how far over that is compared to this wall of this motor, or excuse me, of the extrusion. 22 millimeter offset. That makes sense. Yeah. Well, no, that's not right, is it? No, that does make sense, because you need these NEMA 17 motors are 42 millimeters across. That means you need 21 millimeters from the center to the side, and so there's giving it like 1 millimeter of wiggle room. Okay, and this is the cool thing about doing this is you can see when you start building these printers virtually using SketchUp, which is a completely free program, even though I'm using the pro version. It's completely free, right? You can start to get design principles and be like, oh, okay, yeah, well, yeah, motors should be about 22 millimeters away from the nearest wall at minimum, right? So you could definitely learn a lot. This is how I learned how to design my first 3D printer on my own, is by looking at some of the stuff that other people were doing. All right, this is obviously not the type of shaft we want on here. So I'll tell you what I'm going to do is I'm going to just build a, let's see, the lead screw would be about 4 millimeter radius, so 8 millimeters total, or excuse me, for diameter. And what are they saying? I think it was like it was 30 millimeters more than the expected travel. So I'm going to make this, if you want 300 millimeters travel, which is what we were gunning for in the default configuration, I'm going to go 330 with this, is what it sounds like I need to do. Again, who cares? If I'm wrong about this, I'll fix it later. Now, I'm not going to burden myself by making a real lead screw here. Maybe there's an easy way to do that, but I think I'm just going to do this. All right. So let's move it up. Oh, boy. And this program's sometimes I love this program, and sometimes I absolutely abhor. I hate it, but yeah, there's some frustrating things about SketchUp, I suppose. But that's really true of anything, And hey, for free, not a bad deal. Okay, so let's take this and let's just lock it on the x-axis. Oh, I don't think I did that right. Whatever. I have no idea if that's lined up right, but we are going to find out. And this, I think in this case, should go probably maybe down further to the base of this. Okay. Whatever on that, it's kind of like, we'll see later how that works. Okay, so let's move these together in a group. First of all, the stepper together with the lead screw, make a component, and then that with this. I do not think... Oh. Well, for later, we are going to need a lead screw nut. Okay. So let's go to 3D Warehouse. I found one in here, but if I remember right, it was kind of hard to find. So it was under lead screw. None of these are, now that might, yeah, it's a ball screw. There it is. Perfect. Yes. That looks very similar to the ones that people are using. I knew you had to kind of hunt for it, if I remembered, you know. So let's rotate that 90. And again, it's just so frustrating because I don't know how to reference the center of a circle, right? I have to admit it. So if you watch this, man, and oh, there it goes. Now it wants to reference it. Perfect. Okay, cool. Whatever. Maybe I just needed that straight on orthographic view or whatever, that top view, I guess you could call it. All right. Yeah. Click that. Let's put this and this together. And then we'll put this one on last because this is going to be moved later on once we get the bed on there, and it has to line up with the bed. Okay, cool. So let's put the frame back on there and the X gantry. Everything's looking groovy. And as far as I know, let's take a look. Oh, here he is. He's using an anti-backlash version of this same thing. Ah, I see. So here you can see that does actually stick out slightly at the bottom. Okay, so that was something we looked at earlier. Yeah, you can see that. That's a good view of this. Basically, I have the YouTube video on paused, turned up to HD, even though my crappy internet couldn't probably handle that for streaming. Yeah, all right, so that's cool. Gives us a little view of that. Yeah, whatever. All right, dude, so let's take this one, and it's going to have to move down a bit. I'm pretty sure of that. Let's just go down 20 for now. I don't know. All right, so the next step, what are we going to do next? Let's start. I feel at this point, it would be a good time to adjust the positions of these, okay? Now what I'm going to do is we're going to look back. Actually, let's actually build the frame first. Build the 2020. One of the things I don't like about this design is the fact that if you did it the way, now we're not going to use, eventually I'm going to be designing out all the 2020 extrusion. Again, not that there's anything wrong with that, but I have a CNC machine. So it doesn't make any sense to fidget with all those little things, and each thing could be slightly out of square. Why would you do that? So, all right, so let's take a look. And what we're going to do is we're going to go and we're going to grab this. And where did the configuration go? There it is. So we need to make 2020 extrusions, 2 pieces of each that are 415 and 170 long. And this is 2020. And so there's a 6 millimeter gap in the middle. You can see that it uses up 4, so that leaves 6. So there's a 6 millimeter depth here. And then it rounds off at a radius of 1 on the corner. So let's go ahead and model that. Get a straight top view. Let's throw down a rectangle. A square, yep. And we want to go 20, 20, enter. All right, and what we need to do is we need to, you know what, I feel like there's a better way, there should be a better way to do this than what I'm doing here. This sucks so bad. I'm going to show you something in this. I hate this. One of the things I hate about SketchUp is such a janky program like this. Nope. Because you have such a small radius of 1 millimeter, it's saying, no, there's too many segments in it by default, and it doesn't bother adjusting that for you or anything. Okay, rant over. Let's fix it. So to switch to something else, switch it back to the arcs, and you can see it has sides of 12. I'm going to change that to 4, enter. And so there you can do it. Okay, it's annoying. So you have to do that before you actually start clicking on anything. You have to press 4 enter there. It's just because the arc is so small, and let's face it, this program is so dumb. Like, if some things I love, it's just like, oh man, it's brilliant. SketchUp, good job. And then there's some other things that I find to be yuck, just yuck. Okay, let's go in 7 to the start of that. Down 6, over 6, up 6. And this should be aligned with the midpoint at the bottom, if I did that right. Yes, it is. Okay, so now what I'm going to do is I'm going to select the arc in the square by double-clicking, holding down Shift, and I'm going to do a rotate command. I need to reference this untouched side. Don't reference this one because it's shorter because of the arc we put there. Untouched side, other untouched side will get me there right in the middle once we reference both of them. I'm going to rotate these. You have to click Control, otherwise some really strange things happen. Control makes copies, 90, and then without pressing anything else, star 3. So I press 90, then enter, and then star 3, and we get 3 additional copies, and that does it. Clean this up, grab a corner, delete, grab, delete, grab a corner, delete, grab, delete, grab, delete, grab a corner, delete. Okay, cool. And you know, this was on the at least on the ones I bought. The middle here for me was 5 millimeters, because it was for tapping M6. Some people get the 4.2 millimeter, which is for tapping M5. So, all right, let's go 2.5 for 5 millimeter, because that's at least the type I have. You know, you might want to do something else. It doesn't really matter. This is just to make it look more like extrusion when we model things. Okay, I don't recall exactly. What was that? 415, 170. Okay. Let's go. Whoops. Ooh, we've lost a corner there, didn't we? Okay. So, make a component, create, move it over before we extrude. Make it unique, because this is going to be 170. The other one's going to be 415. And I'm going to push this. Oops. Get in that group. Whoa. 415. 170. I'm old. My memory sucks. 415, 170 was correct. Okay, cool. Okay, so those are the 2 types of lengths we're going to need. This one's going to need to be tipped over on its side. 90 degrees this way. This one right here is going to need to be tipped over this way. And of course, what do those represent? Let's take a look. There it is. That's this. So our 170s would kind of be in this configuration. Our 415s, in our case, are going to go across here. Now his are different lengths because he's using this bed, and we talked about this. This bed's not something I would use. I'd probably use the CR10 version or whatever, but whatever. So that gives us an idea of what we're doing here. Okay, now what I'm going to do is we need to line up this 170. It should be smack dab in the middle of the drawing. Bye-bye, X-Gantry. We do not need you for this part. So it's kind of cool, man. You can get rid of stuff that you're just not going to use right away. Let's align it with the center origin of this. That makes it pretty simple. And you know what I'm going to do? I'm going to actually reference this midpoint here and move it right to the center just for the heck of it. Because, well, why not? First I need to move it down. Oh my God. Okay, cool. So there's that, and let's get a vertical, straight up top view of that. So if we look at it, this is going to actually move right up against that edge. Oh, my dog is tired. I think I'm annoying my dog by talking so much in this video. Whatever. She sleeps all day. It's kind of like what she does for a living, so she can sleep later. It's fine. Okay, there we go. Now, what's going to happen here? Well, this needs to move, and we'll find out exactly how far it moves here. But this needs to move all the way over until it's butted up against here. Looks like a 150.97. I'm just going to call that 151. So probably there's a slight misalignment with this. So I'll just 151, let's say. All right, and so where is this going to be? Well, if we think about this, these are actually lined up fairly accurate to where they're going to be. This needs to be moved now. And where does it need to move? Well, let's see. Right up against this thing. Inside of this piece right here. Okay. Now don't worry too much because they shouldn't, I don't think they're vertically aligned yet. Let's grab these and move them down. Grab it here and move it back up. Yowzers. Okay, there we go. Okay, or maybe it would be better to move it right in the middle. That might be a better idea, but good enough. Okay, so there we go. We've got that part done. Now what do we need to do? Let's see. I think I've come up with I think I've got a pretty good idea of how to do this. So let's see, we will move, let's copy these pieces right now. Actually, yeah, this could be fairly easily copied. And we could reference the other side, but if we think about it, it should be 190, 170 plus the 20 millimeters width. Hopefully I did that right. Yeah, hey, that worked out. This is 151 it had to move, I think, if I remember right. Well, for us, we're going to go 151 times 2. Whoops. 302. That should be about the right place. Okay. And, man, I hope there's some clearance there, isn't there? Let's look from the top. Yep, there is a little bit of a gap there. That's good. If there wasn't, it would be a tragedy because it wouldn't work. Okay, now you notice it's like, why doesn't he make the other ones? Look, what I want to do is I want to make sure that we get everything right in this group before we start copying it. That way my component will maintain its integrity, meaning that when I change one of them, the copy of it gets changed also. So for that, now what I need to do is detach this and get it out of there. So I'm going to explode the last group, which separates this, because in the future, and we're going to explode this group. Ooh, you know what? Let's actually add that right now, that nut holder. Import. Nut bracket. The other one's for T10. That's if you had bigger lead screws. You know. And there we go. Got that. Again, I'm going to take my own advice from earlier and flip it upside down. The correct vertical orientation first. There we go. Okay. And then that makes this next one a lot easier to figure out. Is that right? Yeah, it was on the top of it. Oh, no, it's not right. Okay. Should have been this direction. 90. I feel like that got screwed up somehow. And we're going to reference this side down here. And I want to move it over until it's right there. It's a pretty good design. One thing I noticed about this when I was practicing for this video that I really liked, and yes, I do practice for the videos because you don't want to sit here and watch me work through where to find something and all that. So most of these videos are, I wouldn't call them rehearsed. Well, yeah, I mean, I guess it is. They're somewhat rehearsed. So, okay. So now that that's on oh wait, is it centered? I don't know. I don't think it is. So let's go ahead and grab the middle here and center it with that. Okay, I guess it was centered. Probably, I must have rotated it the exact right way. One thing you can see is that lead screw is definitely not quite tall enough. Maybe it is. Well, I don't know. Okay, now we do this. Let's explode I'm going to get this nut loose from there, so I'm going to explode this. And it's also the reason why a lot of the stuff I'm doing, like, hey, later this will come in handy. You know, the first time I do these videos in practice mode, I don't always come up with those, right? So that's another reason why I rehearse, so I can kind of seemingly see in the future, I suppose. Yeah. Okay, so now let's think about this and let's start copying component pieces to the other side. You know what I'm going to do? I'm actually going to make a component out of these. And this. Okay, so let's see here. First of all, let's get that back on there. Let's move this over. And we're going to flip this along components green. Okay, good. I'm glad that worked, because sometimes when you spin stuff around, that flipping gets a little bit, it can be a bit tricky. All right. So let's reference this inside face down in here and move it on the green axis until it's up against this rail. This video is starting to get very long. I was afraid of that this one's going to be a little bit longer, but that's okay. I don't think, maybe it's not that much longer than the other ones I made though, so whatever, that's fine. Okay, cool. That looks pretty good. And here's another thing that we're going to have to, okay, so let's move it somewhere over here, somewhere close. Flip it along components green, and we get the mirror image of that. And because we have it as a component, anything I change in here will change and update on the new one. Now let's see here. This is an interesting thing. How far off did this end up being from the middle? 74.7. Yeah, well, I guess that doesn't help. Let's reference it right in the middle. And then, okay, cool. Okay, that looks pretty good, and the reason that we got that all set up is I think I'm now ready for a rotation. Let's do this, and we will make all our fancy groups later, okay? We'll get all our grouping right later on. Okay, here, this, this, this. I'm going to delete this. Here, here, here. Make sure I get the nut. Get this lead screw assembly. This one, this one, this one, and this one. I think I've got everything. We're going to do a rotate around the origin, copy it, 180, and there it is. Everything copied to the other side, and now we'll make some groups. Okay, that's cool. I think those should probably be in a group. Well, you know what I'm going to do? This is kind of the stationary part of the Z-axis that's bolted to the frame that doesn't really move in relation to the frame. Maybe you know what? Probably should have made those groups first. So let's go back and undo that rotate that I made. We can always do that later. Let's do all our grouping before this. I think it's a good idea here. Okay, stationary stuff that doesn't move. that. Yep, that's it. Okay, so I'm going to make a component out of that. Cool. So yeah, there's some subgroups in there. We can dig through them if we need to get back at them. Okay, now the rest of the stuff is going to be attached to the bed. So now we'll just grab this component. Bam, bam, bam. Boom. Okay, cool. Nope. I left behind the nut. Shift and grab that guy too. All right, sorry. Abandoning that poor piece of brass there. 180. There we go. Let's see if that works. Yep, still got that little gap in there. Everything seems to be pretty good. Yep, right down the middle. Let's get a top view. Yep, and you can see how he designed that. It's really cool. Is in case this isn't exactly right, he put some slop in him. I mean, you could still tighten down on it, no problem, and it'll be fine. But it kind of gives you some leeway because those extrusions might be, there might be little things here and there that are off. So that's kind of cool. There's a little bit of flexibility built into it with these little slots where the screw can go back and forth in. Of course, once we clamp down the screws, though, it should stay stationary. Again, there's some things I criticize. I'm not really criticizing, but like how I would make them different. I want to give some credit for, like I said, it's amazing. It's amazing printer design. And also, let's give credit to Tech2C, who made the original one that Scott 3D kind of based his modification on. So what I'm doing here is I'm grabbing all the stuff that should be the moving Z-axis, so far, at least, and I'm going to make a component out of those. Great. Cool. Perfection. Okay, so maybe, you know what, I got to admit, maybe I should have put the bed mounts on there first. It's okay, whatever, that's fine. But it would have saved a little bit of work in the long run. But I think, you know what, hey man, we got to just kind of keep trucking forward. So you can see this is a great thing. So what we can do is like, hey, let's see if we did go down 300 millimeters. Move it 300 on the blue axis. Yep. Would it still work? Yes, you can see it has a little bit of leeway there. Same here. Okay, cool. That looks pretty darn good. Let's add the bed. Now the bed, we were in this scenario, we're going to suppose, I guess I don't have it anymore, but remember the CR10 bed. Let's go ahead and draw that one up real quick. Let's get that made. Or actually, let's import the holders for it first. All right, so we're going to import bed bracket 15. Remember, that would be what I consider probably the most rigid version of the bed bracket, right? So we want to rely on the aluminum to kind of support it. If I was going to make it out of aluminum, I would want to rely on that more than I would the extended length on some of those other options for this. Okay, 180 rotation there. And, I'm just going to double check, but I think these go on the top side. And they do, yeah. Just had to look at that YouTube video of his. Oh, and we do need to rotate these like 90 this way so they can go on that rail. Okay, so now we're going to move this guy. You know what? Let's get rid of this 30-30 frame just on the way. Not much, but it's starting to get in the way of the camera a little bit. So again, that's the best part about layers, right? Let's grab this and drop it down onto our 2020 bed extrusion. In a little while, I'm going to make a layer for the bed. So the Z-axis, the moving part of the Z-axis. But I want to kind of get things tidied up first and finished up here. Okay, let's get a good view and make sure it is still, no, it is not centered. That looks better. Cool. So there we go. That looks just right. And let's remember that for the CR10, the offset for the mounting screws for the CR10 bed that I was talking about earlier using, the offset was 240. That means it's 120 in each direction. So I'm going to click Control to make a copy. On the red axis, 120. Move this other one on the red axis, 120. We can go ahead and rotate these. Whoops. Click, select both of those, and we will rotate blue axis, and we're going to rotate these 180. The copies of these 180. And that will put them right up here. Cool. Okay, we're going to use this. We're going to grab this, 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 and this. We're going to make a component. So that will add this to the deal. Go inside there, and let's explode this one so we don't get too many complex groups going on in there. Actually, we probably should, but whatever. Okay, so there we go. And now we have it moving like this thing. And you know what? I shouldn't have even done that until I put the bed on. Let's make the bed over here. So let's get a top view. And we'll get a rectangle. And I could pull it up on Google again, but it's, you know what? I'm actually going to do it right here. If you click, so if I'm using the origin as the center point, that way I won't have to move it around later. Click Control while you're making a rectangle, and then you're going to type in the dimensions. So it centers the rectangle at wherever you started rather than using that for the corner. So I'm going to type in 310, comma, 310. Cool. That's what we want. Let's make a component real quick, just so it doesn't get tangled up with some of these other lines that are laying around there. And I'm going to get into this group. Before we do anything else, reference midpoint. Reference midpoint. Let's just put in some, I think they're M4, but I'll be honest, I think, no, it's M3, I think. I don't know. If not, let's just go 1.5 for now. I think they're actually bigger than that, but it doesn't matter really. Okay, grab this. Whoa, 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 whoa. There it is. Grab that. We're going to move it over 120. We are going to move it down 120. Locked on the y-axis. Nope, sorry. Cool. We're going to rotate them around the middle and do the 90-degree rotation times 3 type of trick. So let's find midpoint. Bed midpoint. Good. Midpoint. Drag up. There it is, referenced. And of course we're going to click Control to copy it. 90 star 3. And it gives you three copies around the thing. Let's just go ahead and delete that. Delete that. This. And this. And I think it's a 3mm thick chunk of aluminum there. Cool. Got our top view. And what's really good is I think it's lined up perfectly, because look, if we move this at all, you start seeing those bed things are there. But when it's on a perfect top view, you don't see them. That's good, man. That means we got all this stuff lined up correctly. You can see those are some pretty whopping big screws you'd use to hold these things up. Okay. Now let's take a look at this and some information on this part. How far up should it be? Now I found this earlier. If I was looking on sheet 1, where was it? It was like Z-axis. Here it is. Z bed travel requirement. No. Z bed height. Distance from the bottom of the Z bearing holder to the print surface. 68mm. From the bottom of the Z bearing holder to the print surface. 68. Okay. So what we're going to do is I'm going to grab this and first line it up so that the distance isn't 68. It's just a 0. That way we can 0 it off. Okay. So there it is. And, oh, it's the print surface, so we have to move it down 3. Sorry. So that should be lined up with the bottom. And it is. Good. Now I'm going to move it up without making a copy. Just lock it on and 68. That's about where it would be. Okay, you know what? We don't have to, but I'm going to grab some springs and throw them in here. I don't even care if these are exactly right, and it's going to be very difficult to find springs exactly the right size. We'll just use the scale tool. I don't know. You don't have to do this, but we don't have to do any of it really, right? Like you can see, I'm kind of inconsistent. Like when it comes to let's grab that one. Looks good. Huh. Some of these springs are better than others. This one looks about the right proportions. Yep, throw it right in the model. Okay, so way too big. Don't worry, it's okay. Right? Let's get a top view. Okay, so what I'm going to do is, first of all, let's see how big this is, right? Roughly speaking, top view it from the edge. So 34. We want this to be probably shrunk down to about 8 millimeters across. So scale factor is new divided by original. The new one that we want is 8. And this other one was 34, I think. And this is just rough. It doesn't matter, right? But, okay, 23.5 scale factor. Okay? So what I'm going to do is I'm going to grab this, and we use a scale tool, something we don't use very often. I don't use very often in here, but click it to start the scaling. Now, you want to use these opposite points when you scale it, because that'll scale everything, and then we'll stretch it or cut it off depending on how big how tall we want it. Okay, so it was 23.5, so I'm going to click it once and start it. Once you start it, you go 0.235. And there it is. Again, I don't know, maybe that's too big or too tall or whatever. You know what? I think actually it is going to be too tall. Okay, well, that's fine, I suppose. Let's move this vertically until we're down here. You know what? Actually, let's not do that. Let's move this so it's basically in the middle. And then we can just do the offset by 120, 120, because it's, 240 total. All right, so let's go. Close enough for government work. And let's copy it. 120. Make a component out of this too, by the way. Oh, it is. Okay, good. And let's move it 120 this way. All right, and delete this thing. Whoops, I didn't grab what I wanted to rotate. Let's do this first. And you can see, even looking there, it's a little off, but whatever. This part probably isn't really even necessary. 90 degrees. Times 3, star 3. Yep, there they are. Let's grab all those straight on front view, and let's move them down. About there. Okay, you know what? It looks good enough. And they don't stick out past this, so we'll just pretend that they just stop right there. Whatever. That's, like I said, it's good enough. And it adds a good look to the thing. And you can kind of see how it goes. Okay, we're going to grab all those, make a component. And you know what? We could go in there and just explode this because we made a subgroup. And that's fine, man. Now what we have is a z-axis going up and down. Let's actually, let's make ourselves a layer and put this on there. So we'll go here and z-axis. Or you could call it a z-carriage, right? I guess, I don't know. Okay, there you go. So now the z-axis is, no, it isn't. I have to actually put it on that layer. Cool. Now that can come and go. X-axis, the X gantry can come and go. And the 3030 frame can come and go. So we have these all, or not everything, but a lot of it's in components. All right. So I think that will accomplish pretty much what I wanted to achieve with this video. However, you can see we have a problem that we'll need to address, is that these, and I think part of this might be the fact that we saw that a little bit stuck out the bottom there, and we'll fix this later, but for now I'm going to leave that alone. And I think part of it has to do with the fact that he's using these shorter lead screw integrated steppers. So if you use the longer 48 millimeters, you can see this might be a problem. Hey, that's why we build it in advance on SketchUp. Okay, so where are we going to go from here? We've got the basics of this printer. Ooh, we have a copy down here. We have the basics of this printer ready to go. We can basically see everything on there. We may actually do another video where we put components on the back that might need to be relocated, but like the electronics and stuff like that, I'm going to leave that for later because that stuff is so specific to the build. I think I'm going to probably leave that off until we do the rework. I might actually put some fillers back there, like a rectangle that represents the power supply, another rectangular box that represents the electronics. But for right now, I'd say we've accomplished what we've set off to do in this video, and that is the Z-axis. So let's move this down. And again, why do we do this? So it's important, man. This is really important to me. So we can see, did we do it right? Well, look at that, man. That's right smack on the money, right? Like if this distance is like 0.3, we got a good first layer, right? Like 0.76. So that's one reason why we do it. And of course, these springs that can be adjusted upward, of course. Probably would want to. But then look at what we can do at this point. And this is why we're doing this. I just want to do this before we move on, even though it's not important for this video, is now we can say, hey, man, what if the printer was all the way at the end of its travel going this way? Make a copy, move it over 150. Okay? Make another copy, move this over 150. Okay, this would represent when it's in the middle. These would never be on there together, obviously. They wouldn't be on three at once. But I think you're starting to see the point. The point of why this is cool is now you can see like, oh, that's as far as it goes. When stuff sticks up, can I put something here or there? You know now. Now you know for sure. You know exactly the extent of its travel. Let's move it forward 150, for example. And let's move it backwards on the green axis, y-axis, 150. So you can start thinking like, hey, if I put something back here, am I going to have room? Is that going to actually fit? Now you know. You can tell for sure. And you can see here too, you can see there's a problem with the way I did that. This is all going to have to be shifted a little bit because why? Well, look what I just discovered. That the way I had built it, it would have collided with this to even get to the maximum print position. And that I didn't offset it for the nozzle. So we'll do that in a later video, but I just want to show you. And another thing we can do with the Z-axis, for example. Hey, what would happen if it is all the way down, 300? And then what about midway, about the midway, 150 down? Yeah, okay. And again, these would never all be on there in real life, but you can kind of see, do I have room to put this thing here or there or whatever? You don't need to guess. That's the thing, right? So I would say that that's, again, the main benefit of doing it this way. So there we have it. And I'm going to go ahead and save this. And thanks if you tuned in and you are watching through this series. Hey, man, this is my first kind of series of videos that I've been doing. Basically, my philosophy is I just want to just get through and do the first one, even if it's poorly, and just get it out of the way. So the first is the worst, right? That's my philosophy is you just jump in there and do it, and then later you'll get better at it. So thanks for hanging in there for this part of it. And so in the future, we're going to start future videos. We're looking at now we're going to start pulling out the frame pieces. Or, well, they're layered, so we can disappear them and reappear them and start replacing them with sections that represents material. What material? Well, it could be MDF. It could be nice, fancy-looking plywood. It could be aluminum if your CNC machine is capable of cutting sheets of aluminum. It could be steel if you have access to a plasma cutter or, I'm not sure, water jet, whatever they use for that. I'm not very obviously I don't know what I'm talking about. Or, you know, like in my case, I'm kind of leaning towards a aluminum composite material like Dibond, a cool sign material. So that's what we'll do. It's in the future, we'll do it, and we'll do that roughly in SketchUp. Just to see, does everything fit? Is it going to run into this? Is it going to run into that? Do we need more space? Whatever. We're going to do all the rough design in SketchUp. And then from there, to make the actual any STL files or DXF files for laser cutting, or, you know, if you're going to CNC it, from there we will put it into a real CAD software. Probably in my case, I'm going to be using Onshape, although people tend to prefer Fusion, and I can see why. Just unfortunately, I got into Onshape before Fusion was really big and easy and free. Or maybe it was already, and I just chose the wrong one. And so I'm not that great at Onshape, or excuse me, at Fusion. So again, we're not going to stay in SketchUp forever. It's just a SketchUp. It's a sketch. It's a rough draft. Thanks for listening.